This is the final one of us building this little game. It's not a full game, but I wanted to show you what you can do with Canvas. And if you're truly interested, let me know in the comments below. If you want me to add more features or anything, maybe I'll make a specific game development using HTML Canvas video about it. I've had more ideas, for example, increasing the speed, having a pause button, maybe adding some graphics, stuff like this. But this is a Canvas tutorial, so I don't want to get too far astray here and get back to designing using HTML Canvas in this playlist or in this project of mine. But if there's general interest in expanding this game, let me know and I'll dedicate some time to do that. Having said that, we'll go back to what we've had from the last tutorial. There's no collision added. Now we have a score, still 2 animated circles. And now we want to have a collision and we want to have kind of like a game over function running when a collision has happened. To be able to do that, I've simply added an animation ID right here. I've just declared a new variable, you could say, and use that name. And we need that later for our game over function. And we also need to add a collision function. As the collision function is going to use the game over, let's write that first. And we'll use our animation ID right here, the variable that we've created. We can use cancel animation frame. We've earlier used request animation frame. So it's basically the same one of these, let's say, keywords inbuilt that we can use to just cancel the entire animation that we've created for blue and green. And we want to have an alert shown. The browser can do that. It pops up a message. And in this case, we just want game over. And then the final score should be displayed. So your final score and then plus our variable, which was score. We've created that in one of the earlier tutorials. And here you can see it, it's 47. And here is the let score equals 0, which we've created initially. Alright, finally, we need to take care of the collision. This one is a little bit trickier. It takes some math. And here I have my typical typo. It's function, not fungiton, whatever. Let us start here. We need to store the positions of our objects. We have 3. We have red, so don't forget that, blue and green. And then we store that in red X, red Y, blue X, blue Y, green X, green Y. So the idea is to find the current position of our 3 objects and then store them as values in new variables. This one's still pretty straightforward. Just let me change the names. And I have to be careful not to mix things up. It's always XY, 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 and then red, blue, green. We should be good here. And now we can use these values to check if there's an overlap between our three objects. And there's a simple way to do it. It takes some math. I believe in English it's called Pythagorean. In Germany we just call it Pythagoras. So it's this ancient mathematician which has given us a square plus b square equals c square. And we use that for distance to blue and distance to green. And then we'll check if these values, so these new variables, distance to blue and distance to green, if they are smaller than the radius of red plus blue or red plus green. And if this is the case, we know we have a collision and then we want to call the game over function. For now, I've left distance to blue and distance to green empty. So I'm going to explain it later on, but this is c square. And we'll add red circle radius and blue circle radius to determine that. And we need both because we want to have the edges of both circles when they hit each other and not just the center of one of these circles. Therefore, we need both circles.radius. And as I've said, we then want to call game over. Same goes for distance to green. We just have to change the name to red circle.radius plus green circle plus radius. Once again, we call game over if this is the case. I think that's still pretty easy to understand. But now distance to blue and distance to green, as I've said, it's c square. And if I just open a simple paint document and I draw that by hand, so it's not going to be perfect, but you'll get it. Here we have a blue circle. And I'll make this one red. And now from the center position, they both have an X and a Y value. Let me indicate that with these lines. Put them somewhat in center. And it was a little bit too high, but you get the idea for the blue one. It should be in center of it, and for the red one as well. And if we now connect that, we have a triangle. Maybe I'll make that, let me pick a blue color or a green one. That's better. We have a blue circle, so I make this triangle green. And here now we have a square plus b square equals c square. You know that, I believe, from school. It's nothing new. But we can use this connection to determine the distance between red and blue with c square. So c square is the big one here. In German we call that Hypotenuse. I don't know the English word. Hypotenuse, whatever. But this is what we're calculating with distance to blue and distance to green. And then we want to store it there, and then we'll compare it to red circle radius plus blue circle radius. And if it's smaller than that, we know that these circles overlap and we have a collision. We can use math.sqrt, which is for the square. And then we need a square, which is red x minus blue x. Then two of these star symbols 2, which is square 2. And then plus red y minus blue y. And this will give us the b square. In simple terms, this is what we have calculated here and then stored. So c square is stored, and the other two values are a square and b square. As I said, it's drawn by hand, so I'm not going to win a design prize with this. It was just for explanation. We can copy paste this entire code line for distance to green, and then we only have to change blue to green. Same reasoning applies here. We use this Pythagorean principle. Let me add this here as a simple comment. As I've said, if c square is smaller than red circle radius or radius of direct circle and one of these other ones, we know that there is a collision. Let me clean up my code a little bit. There are a lot of comments that we don't actually need, and that makes the code a little bit unreadable. And then I'll come back and show you the final results, and we'll go over what we've added once more. So here we are again, and if I move the red one downwards, you can see it gets hit by green, and then this alert is being shown and it shows game over. Your score is 1 because one blue one has already passed. You have to refresh the window if you want to restart the game. This is one feature that we could add in real game, but I don't want to go too deep in this HTML canvas playlist. So once again, if you're interested, let me know and I might invest some time into creating real game. Let's go over it again. Here are red, circle blue, circle green, circle the objects. Here we have added our animation ID that we've later used in our game over function. I'll scroll down. Here's our function for checking the collision, and below is the function to handle the game over. Collision, we've stored the 6 values for the positions of our circles, red, blue, green, x and y for each. And then we have calculated distance to blue, this c square that I've explained in my very artistic design. We've stored them in distance to green and distance to blue, and then we've compared them if they are smaller than the radius of red plus one of these other circles. And if this is the case, we know that c square is smaller, and when c square is smaller than the radius of red plus one of these two circles, we know that the distance between them is smaller than the two radius values combined, and this makes it an overlap, therefore a collision, and will trigger the game over function. This is why this works. Here, once again, our handle game over. There's the stop animation and then the alert. As you can see, it looks a little bit different from browser to browser, but it displays the score. And this concludes our little canvas game. So stuff like this is possible using HTML canvas only. It's obviously a little bit JavaScript involved, so you need to understand that stuff. Now I will proceed with HTML canvas, a little bit more design focused and less game focused. But I hope it's still going to be interesting. Thank you for watching, and I'll see you next time.